group of researchers is attempting to bounce radio signals off a 500-foot-wide asteroid during its close flyby of Earth on Tuesday. The high-frequency Active Auroral Research Program, Haarp, is aiming its antennas at asteroid 2010 XC15, a space rock that's categorized as a near-Earth, potentially hazardous asteroid. The effort is a test run to prepare for a larger object, known as Apophis, that will have a close encounter with our planet in 2029. What's new and what we are trying to do is probe asteroid interiors with long wavelength radars and radio telescopes from the ground, Mark Haynes, lead investigator on the project and a radar systems engineer at NASA's Jet Propulsion Laboratory in Southern California, said in a statement. Longer wavelengths can penetrate the interior of an object much better than the radio wavelengths used for communication. Haarp is a research facility in Gacona, Alaska, one that's been the subject of plenty of conspiracy theories. It's made up of 180 high-frequency antennas, each standing at 72 feet tall and stretched across 33 acres. The facility transmits radio beams toward the ionosphere, the ionized part of the atmosphere that's located about 50 to 400 miles, 80 to 600 kilometers, above Earth's surface. Haarp sends radio signals to the ionosphere and waits to see how they return, in an effort to measure the disturbances caused by the sun, among other things. The facility launched a science campaign in October with 13 experiments, including one that involved bouncing signals off the moon. At the time, Haarp researchers were considering sending a radio signal to an asteroid to investigate the interior of the rocky body. During today's experiment, the Haarp antennas in Alaska will transmit the radio signals to the asteroid, and then scientists will check if the reflected signals arrive at antenna arrays at the University of New Mexico Long Wavelength Array and California's Owens Valley Radio Observatory Long Wavelength Array. Haarp will transmit a continually chirping signal at slightly above and below 9.6 megahertz. The chirp will repeat at 2-second intervals. At its closest approach on December 27th, the asteroid will be twice as far as the Moon is from Earth. Tuesday's experiment is to prepare for an upcoming encounter with an asteroid in 2029. That potentially hazardous asteroid, formerly known as 99942 Apophis, is around 1,210 feet, 370 meters, wide, and it will come to within 20,000 miles, 32,000 kilometers, of Earth on April 13, 2029. The near-Earth object was thought to pose a slight risk to Earth in 2068, but NASA ruled that out. Wants to probe the asteroid to prepare for potential risks in the future from space rocks. The more time there is before a potential impact, the more options there are to try to deflect it. In September, NASA's DART spacecraft smacked into a small asteroid and successfully altered its orbit. Such a strategy could be one way to divert a space rock that threatens Earth. Today's test shows the potential of using long-wavelength radio signals to probe the interiors of asteroids. If we can get the ground-based systems up and running, then that will give us a lot of chances to try to do interior sensing of these objects.